individual, etc. I would like to start the conversation a little more into the area of machine learning. And again, I brought you a couple of examples. So this first example, and if anybody knows this, this has been around for a while now. Please don't spoil it for others, but so this is what's going on here. So this is a conversation. The lady is interviewing this guy. So blah blah blah, music online. Guy Cuny is the editor of the technology website News Wireless. And he's like, "Good morning. Were you surprised to see this verdict today?" And this is about Apple Music, or Apple being sued by Apple Records, which is the label of the Beatles, I think. And like they were like, because they introduced iTunes, that was the first time that Apple did something with music, and so Apple Music or the Apple Records got upset about that. So they were like, that's kind of like the story about this. And so he's like, "Oh, I'm very surprised to see this verdict because I was not expecting that, blah, blah, blah. Yeah, big surprise, exactly, yeah, okay." So what is really going on here? So this guy is surprised about this verdict, and let's listen to this conversation.
Need for the industry and the growth of music online. Well, Guy Cuny is the editor of the technology website News Wireless. Hello, good morning to you.
Good morning.
Were you surprised by this verdict today?
I'm very surprised to see this verdict to come on me, because I was not expecting that. When I came, they told me something else, and I'm coming. You got an interview, so it's a very big surprise anyway.
A big surprise.
Exactly.
Yes, yeah. With regards to the cost that's involved, do you think now more people will be downloading online?
Actually, if you can go everywhere, you're going to see a lot of people downloading to the internet and your website, everything they want. But I think it's much better for the development and to improve people what they want and to get on an easy way and so fast the things they're looking for.
This does really seem to be the way the music is made for the industry and the growth of music online.
God, this is annoying. All right. Anyway, so you saw this conversation go like a bit back and forth. It doesn't really nothing crazy is going on, I would say. But let's
Made for
see
the industry and the growth of music online. Well, Guy Cuny is the editor of the technology website News Wireless. Hello, good morning to you.
Good morning.
Were you surprised by this verdict today?
I'm very surprised to see this verdict to come on me, because I was not expecting that. When I came, they told me something else, and I'm coming. You got an interview, so it's a very big surprise anyway.
A big surprise.
Exactly.
Yes, yeah. With regards to the cost that's
Okay, this is going on. I don't know how long this video is. Anyway, so basically what you saw there is like suddenly after you've listened to it, read the conversation, and suddenly we had some laughter going on because, well, obviously this guy has no clue why he's here, and he's Guy Cuny, but his name is Guy Cuny, but he's not that Guy Cuny that they were looking for. And so he was picked up by this news channel and basically brought here. And so you can see that again, like a good example for this is there is a lot going on in conversations, and so multimodal information can help you disambiguate these kind of things. So really, this is one of the challenges of, or the opportunities of machine learning, or multimodal machine learning in this context, so where we can inform the decision of the machine through all the channels. And if sometimes you just have one channel as information input, you don't really know what to think of this interaction. So the challenges that we work on in machine learning are first the behavior sensing. So you need to pick up the facial expressions, you need to pick up the gestures, the voice inflections, the verbal content, etc. Then you want to identify the temporal dynamics, like what's going on over time. can I pick up the relationship between the two individuals, like how's their synchrony, how their relationship towards each other, how is an individual's behavior. Then the third challenge is basically the multimodal fusion, the fusion of information in a meaningful way, and we're going to talk a bit about this today, but then also go into a lot of more detail later on during the course, like how we can meaningfully fusion information from all these channels. And then lastly, obviously one of the most important and most difficult tasks for a machine learning algorithm is to appropriately interpret what is being observed. So these are kind of like the challenges. And so as an overview, we have basically visual markers like gestures, head gestures, eye gestures, arm gestures, the body language, posture, proxemics, eye contact, head gaze, eye gaze, etc. Facial expressions, we talked about action units and smiles and frowning. The verbal content, the lexicon, the words, the syntax, the part of speech, dependencies, the pragmatics, discourse acts, like am I asking a question, am I giving a command, and then also the acoustic information or the auditory information about the intonation, the voice quality, as well as vocal expressions like laughter. And laughter, in a sense, actually is a pretty cool multimodal concept where you have something going on in the face, you have something like heavy laughter makes your body move as well, and your voice is changing as well. So what we want to do with this, so we want to take all of this information and get at these concepts, or want to create these interpretations about emotion. We want to know about a person's anxiety, valence, which we'll introduce as well, arousal, like so valence is kind of like how positive or negative the emotion is. The arousal is like how hard, like how high the intensity of the emotion is. Like anger is a low valence but high arousal emotion. Happy is a high valence and a high arousal emotion. And sadness is a high negative valence and a low intensity or low arousal emotion, for example. And you can imagine this already kind of like a two-dimensional kind of shape. And if we want to understand social aspects like engagement, defensiveness, or rapport building between individuals, we want to know in the case of a virtual human, for example, we want to know when is a good time to give a back channel, when is a good time to take the turn from the human, or like to build kind of like this common ground knowledge of common gestures that the person used before, or the vocabulary to engage or to train with the individual. Then obviously we're interested in the verbal content as well. So you can use all of these inputs to better understand the contents of the story. Because the words alone not necessarily inform you about what's going on, but together with the facial expressions and the voice. So to put this on like a complexity scale, on the one side you have the sensing, where you have the cameras and the microphones, and you want to pick up this information. You want to be like reduce the noise. You want to create very robust like tracking devices that never lose the face, even though you put a hand in front of the face and stuff like that. So you want to improve your sensing on this side of the complexity scale, and then lastly you want to start understanding what's going on. So in the sensing side, what we have, for example, we have Kinect sensors. They got a lot better. This is the old one. The new Kinect sensor does facial expressions. It does even like the hand open and close kind of gestures. There's the Gavam or open face head tracker that we talked briefly about. CoverRap, for example, as a collaborative voice analysis repository. You have the links at the end of these slides, which are also actually online on Blackboard. And lastly, we also started to incorporate physiological sensors where you can get, like, for example, the heart rate of an individual. So we have this kind of technology at ICT and we are fusing all this kind of stuff, and so we can put this kind of again back into the 4 challenges that we had before. So we have our sensing challenges. We want to get at like a frame-wise basis. We want to get all the features, but then we want to also incorporate this to understand behavior or the temporal dynamics. So for example, if you see a frame of a head like this, you don't know if the person is within like a head nod or not, so you need to incorporate temporal dynamics. And then you want to at some point fuse the information that you get at this level maybe, and then at the end you want to interpret the information, but then also one of the important things that you kind of want to bring in is kind of like the context. So what is the culture that these individuals are embedded in? What is their personality, etc. And that gets really into the weeds and very complicated. So often what you want to do in a study is to reduce the context as far as possible. You want to understand their personality by like maybe giving them like a questionnaire. You understand, okay, so you have to, you know what this person is, you get their demographics, but then also you want to just manipulate 1 or 2 variables. You don't want to have the most diverse group in the world. So, and here the importance of machine learning on all of these kind of categories is quite important, and so what we're doing with machine learning in the human communication area is we use a lot of the prior knowledge. We try to use, for example, the knowledge that we have about facial expressions, about the voice, the dynamics between individuals, and we want to build machine learning algorithms that are capable of modeling whatever these guys in the 90s or 60s or whenever came up with. And so we use a lot of this information to create meaningful models. But then we also want to kind of expand on these models by getting our own data sets, because a lot of times back in the days, the annotation schemes were quite complex or not like targeted towards what a machine learning algorithm or what a sensing or tracking algorithm can really do. So we rely a lot on like our manually annotated data sets. But then now with the rise of the internet and the data sources online, you can start to increase those data sets massively by just like crawling YouTube, for example. You can, I don't know, download 1 million vlogs from YouTube or whatever site you want, and then basically try to understand how communication or how vlogs work, what the emotion is of the vlogger right now, for example. But you don't really get like fine-grained labels, because if you want to employ individuals that annotate every facial expression on 1 million videos, you're never going to be done. And one of the solutions to this is kind of Amazon Mechanical Turk, where you can throw human intelligence tasks to individuals online, and they basically do the task for you, so you can spread your task to 1 million of people. But so we use all of these kind of sources to approach our challenges, where we want to model the dynamics of individuals. So these are kind of like our machine learning challenges, and in machine learning we can combine all this information in our statistical analysis, our data-driven machine learning, and the probabilistic models that we're going to talk about in this class, and so we try to really tease out all this information from these sources to get at our tasks or our challenges. And with machine learning, because it's so flexible and so widely applicable, it has opportunities for many kind of areas. On the one hand side, human-computer interaction, it gets better by the minute. We want to improve on that, but also we want to improve on interpreting human-human interaction in the space of learning, like Mathieu is doing. in the space of negotiation, like Sue is working on, for example, and also the medical domain that I'm also very interested in. So just to kind of get at a couple of different tasks that you could be interested in. So in the medical domain, you want to understand depression, PTSD, or distress. In education, you want to understand engagement, dominance in individual groups, or in business tasks, for example, frustration, agreement, and these kind of things. All right, so how does multimodal fusion now kind of come into this task? So what we have most of the time is we have information about the voice, the words, the pitch of an individual. We also know the gaze maybe. And now we want to kind of combine all these resources in a kind of like an abstract way. So one of the things that this basically represents is that we combine in a fusion algorithm what is going on here. And so this is very abstract, and we're gonna get into details on like how these fusion algorithms work precisely at a later stage in the course. But the opportunities here are really the disambiguation, as we saw in the example, the robustness to noise, the recovery of unseen data. So I might be able to recover what the mouth is doing by listening to the voice, and to reveal hidden dynamics that we otherwise wouldn't have access to. So one example for multimodal fusion would be, for example, the audiovisual speech recognition that has been around for a while. And so in this case, you have the audio signal, but also you track kind of like the shape of the mouth, and you want to basically recognize what the person's saying. The person's saying something about on the computer way too much, and it's bothering her, so she's telling. So this is one example where you try to incorporate information about the face, or the voice, face of the mouth in this case, and the voice. And so do you think the newest and the best speech recognition algorithms are using this information right now? Nope, they don't. And there's a reason for that, and I'm going to get to that in a second. But before we do that, we're going to talk a little bit about two options of fusion. And one of the options, one of the like the most popular ones, is basically an option of early fusion, where you combine all the features into one giant vector here, and you just basically concatenate the input from the voice, from the face, and the gaze, etc., onto one giant vector, and you throw it into a classifier. So that's one way to do it. Does anybody have an idea of like what could be bothering here, what could be a problem in this case?
Dimensionally? The number of dimensions?
The dimensionality is a big problem, like cursive dimensionality. We're going to get to that later on. Another problem is that, for example, if you think about cameras sample at 30 frames per second, while a microphone samples at a very different rate, for example, like 16 kilohertz. So synchronization can be a problem. And many other kind of issues. Synchronization in both the frame level, but also the synchronization of the channels themselves. There is not many hardware devices that talk to your computer directly that can like incorporate information from all sources at the same time. In our multisense technology, for example, we only combine information on a software basis. So it's not very, very accurate. Like it's not down to the microsecond or something like that. But it's fairly accurate. Another option to do fusion is to do late fusion, where you build classifiers on each modality separately, and then at the later stage, once you have made decisions here, you kind of combine them. So a couple of options here would be, for example, majority voting. So you have an uneven or an odd number of classifiers here. Everybody says yes or no, and then at the end you look who has more votes, yes or no, and then you make the decision, say, okay, this is now a yes or this is now a no. So this is one other option to combine these classifiers. In both cases you have basically two challenges. First challenge is like how to combine these outputs, or how to combine the base learners or the information in a useful and a meaningful way. And the other one is like how do you ensure, or how do you generate learners that complement each other? So one example, for example here, if all these classifiers make the same mistakes, do you think they can learn from each other? I don't think so. So what you really need to create is diversity. And an analogy here is obviously like, for example, if you learn with somebody all the time and you kind of have the same knowledge, it doesn't really improve if you have the same group all the time. But if you might like bring in individuals from other perspectives, you might solve a problem with a lot more ease than otherwise. So this is really like kind of the idea of diversity, and you need to have two goals in mind. So on the one hand side, you want to maximize the individual accuracies, but also increase or maximize the diversity. And back to the example, well, why this is not being used is because these two signals are very correlated and they're not very diverse. And the mouth shape is directly linked to the acoustic information, and that is really one of the reasons why this doesn't work. The other reason is because you have to have a microphone and a camera always pointed at the face. So that's one of the reasons why the newest classifiers don't really use this kind of additional information in speech recognition. So one way to achieve diversity, for example, is to have different kinds of classifiers. We're going to talk about all of these. So on the one hand side, you have multi-layer perceptrons, which you can also exchange with deep learning if you want. You have support vector machines and hidden Markov models. You can replace those hidden Markov models with the famous long short-term memory neural networks. And so basically, these classifiers bring diversity into the mix because they might look for different things. So this guy here looks for sequences, while these two don't, right? And so this could be something that's important in this context. And then another way to introduce diversity is to bring in information from different sources. So maybe if the audio and the video input are too correlated, maybe something like physiological data might help to get you the diverse information that you need. All right. Before I confuse you too much with this kind of stuff, and we're going to get into a lot more detail on this, I would like to walk you through a little bit of the course and how the course is organized. And so we are working with this current version of the syllabus. Basically, the most important information, and I'm going to add TA. I don't know, I don't see what's going on there. I should probably synchronize this. Like this. Okay. Okay. Not bad. Oh yeah. Okay. So we're going to upload that. This is already uploaded to Blackboard, but we're also going to upload it to the course website on USC. So basically, I think all of you have read this. We have talked about this today. The format, well, we're going to have, as I said, one day in the week, like lectures like today, then the other day of the week, we're going to have more of an interactive kind of course where half of the class will be organized by you in discussions where you can present ideas, problems. You can use the reading assignments as like kickoff points of discussion or problems that you might have encountered. So we really ask you to kind of bring maybe some video or like bring some slides with questions on it, with ideas on it, and try to basically engage the rest of the class into a conversation about these things. And Mathieu and myself, and maybe sometimes Lixing as well, will be here, but I hope that we don't have to like lead the discussion, and most of the time you guys are speaking about your ideas. You've seen the course materials. These books are really optional. You don't have to like read all of them. We take chapters here and there from those, but it's not really required that you have like one course book that you learn from start to finish. The course is not focused on like an exam, so you might have seen this, that there's not a midterm and not an exam, and there's not going to be any like quizzes or whatever. The class is really about discourse, about communication between you guys, and at the end the course project. So today we had the introduction, communication models, and by the way, I don't know where some of the slides went. I just realized that. Oh yeah, I skipped a whole section. We're gonna get back to that at some point. And so we're going to talk about on Wednesday about the communication models and the local messages. That is here mentioned as week 2, but it's actually just a Wednesday of this week, or it's kind of like lecture 2. And then we have visual messages, so we're going to talk about facial expressions and tools that you can use to analyze facial expressions like multisense or open face, and so on. Then we're going to have our first full week of machine learning. We're going to introduce the concept of machine learning more closely, and then we're going to go into a couple of classifiers, and then in the discussion, on the discussion day, we're going to get into some detail about like what toolboxes are out there, what you can use for your course projects, for the homeworks. And one of the most important things that I'm going to try to explain to you is evaluation of machine learning projects. We're going to have a few slides on this, and like I don't want anybody to not follow that strategy. No cheating in the results presentation of the machine learning. So like I've seen a lot of papers where people claim to have 95% accuracy, but really what they did is not evaluated properly, and it really should be 70% accuracy and not 95%. So that often gets you into trouble when you want to like work on the same data set, but you have to now prove that you're better than 95%, but like how can I, because it's not possible. So this is something that kind of like a pet peeve of mine, so I want to make sure that you hear about like how the rigorous testing should be designed. We're going to talk about study design, so maybe some of you guys want to run a study yourself for the course project. You might want to invite individuals to talk to your virtual human, or you might want to record 2 individuals talking to each other. But then also we're going to talk about statistical testing in this course, where for example you want to understand like, okay, so I have this dependent variable of smiles, for example. So I want to understand how many times a person smiles, but then I manipulate the task one way or the other, and I want to measure if my manipulation actually changes the facial expressions of the individual. So we're going to talk about statistical tests. And then we're going to go into virtual humans, and actually week 6 is also the week where the first homework will be due. We're going to talk about this in a second. Then we're going to have a guest lecture by John Gratch about effective computing and effective messages. So this is going to be really exciting. We're going to talk about verbal messages. So what can you convey about emotion and affect, etc. in the verbal content of communication. Then we're going to have a series of 3 lectures on multimodal behavior recognition or understanding. We're going to go into a lot of the concepts of fusion. We're going to talk about new algorithms and classifiers, and possibly some representation learning algorithms that I'm currently working on right now, and that's going to be very exciting. We are looking for a guest lecture here because we are both traveling, Mathieu and myself. It might be a good time, so that's also kind of like why the homework is due in this week. It might be a good time for you guys to just think about practical aspects and work on the homework this time, but we are still looking for somebody who can give a guest lecture. I'm thinking about Panayotis from EE, or maybe Hao Li from computer science as a computer graphics person, maybe some person who does social network analysis, so you get some additional like Facebook analysis kind of ideas, or Twitter analysis, which we are not covering in this course because it's not face-to-face interaction or human communication, but it's also a very important aspect of human communication. So we're trying to get you somebody to present, and I think it will be some exciting lecture. And lastly, here we're going to talk about, again, multimodal fusion more deeply, I think, and talk about fuzzy machine learning, where decisions are uncertain and we don't really know what's like if the observed decision is true or false, or if it's like partly true, and so on. So this is going to be an interesting one, and then we're going to close the lectures with dyadic analyses, where we try to understand like how dyads can be analyzed, how we can use machine learning to understand dyadic interactions a bit better. Then there's going to be Thanksgiving, and the last week will be entirely presentations by you guys from your course projects, and this is really what we are going to have to talk about in a second after we talk about the homework. So the homework is really to help you. It's not something that like we see as like an obstacle. So it's really like we have designed a 2-part homework. It's going to be on the same data set both times. In the first week, or in the first part, you're really going to have like a data hands-on experience. You're going to look at the data, you're going to identify things that you're interested in, you're going to get extracted features, but you're going to have to evaluate those features, like measure the amount of smiles, and like really something that you're going to have to do with your course project as well. Okay? And then the second part is some machine learning hands-on, where you are going to compare like 1 or 2 or 3 classifiers against each other. You're going to try out like a classifier that looks at the sequence and one that doesn't, and then you're going to compare like, okay, so this one is better at this, and this one is better at that, and you're going to have to like write up a couple of paragraphs, and provide some confusion matrix, some evaluations, some scores, some accuracy measures, etc. We're all going to talk about this during the lecture. So this kind of like the 2-part kind of homework that we have envisioned. And then for the course project, we have the following in mind. we would like you, because we are almost 50 people, we would like you to find teams of 5, and we would like you to do this now and in the next week, because there is already, and this is also for kind of your protection, there is a proposal draft due 3 weeks from now, okay? And this draft doesn't have to be a lot. Like, this is really for you to have a topic and an idea of maybe 1 or 2 or 3 data sets, and you say, okay, I would like to investigate this and this data set, I would like to investigate this and that data set, and this and that, and then we're going to come back to you and say, okay, this is realistic, this is not realistic, try to do this, maybe you can like combine these 2 ideas into one. So we're going to try to give you feedback as good as possible, but we're not going to be able to give you feedback on like 30 projects, right? So we want to reduce it to really 10, where we can give you appropriate and good feedback, and we would like to see a list of individuals that are on this project and what their tasks will be, like what you anticipate. Okay, this person is going to work on data collection, data analysis, and feature extraction. This person is going to work on the hidden Markov models. This person is going to work on the evaluation or the comparison or the literature review, etc. So just to see what everybody is kind of planned to be doing. If they're doing that in the end, doesn't really matter. We just want to know who is on it and that you have a plan to go forward. Then you're gonna get this back, and you're gonna get some feedback back. But then we're also gonna have a proposal due, which is then kind of like the extension of the pre-proposal, which you're focusing on one task now. You have identified what task that will be, what data set you will be looking at. Maybe you are collecting your own data set, that is possible too, and so on. So this is kind of like what's happening there. And then it's going to be, whoops. And this is really like pretty late, but we might have to move this up a little bit so that like the midterm report will be due, where you are going to have some analysis on your on your data set, some feature extractions, etc., but not like the final results. But you might have a plan of what the classifiers will look like, and then the final projects are due at the end, obviously, and also the presentation. So this is going to be really like at the end, you're going to be mostly working on the course project. And I'm sorry, but like this will probably be a good week to work on the project. All right. So as I said, it's kind of like an important part of the course. I think we're going to move the midterm report a bit up because it's too close. And then, so it's staggered in like four phases: the pre-proposal, the proposal, midterm, and final. And really, you're kind of free to work more or less on these early on, later on, etc. But this is kind of like a sequence where we want to make sure that we can pull the handbrake if we need to and say, okay, like this is not going anywhere. Let's do something else, right? And so we want to know this as early as possible. And then there's going to be a final presentation the last week of the course, and just kind of like philosophically, what I think this course project should be or could be is that if you put in quite a bit of effort and you're willing to work maybe after the course is over, so this course is intense until December 2nd, when all the classes end. But then you're not going to have to study for a final, so that's kind of cool. But what you could be doing then, and maybe over Christmas, is finalize the course project into a paper, and we're going to submit it together to some workshop, to a conference, and you're going to have like a scientific publication. So that would be kind of like the ideal idea of the course project. And we really want to give you kind of like a science, academic kind of hands-on experience with this. Yeah, there are a few things that need to be done. It must be multimodal. It must be at least 2 modalities. We can talk about if you want to only use video, then maybe you can do that, but then you need to have at least 2 individuals talking to each other in each of the conversations. So either multimodal or multi-party. There's no excuse if that's not possible. And then it must include some machine learning, and you need to kind of like compare, make a rigorous evaluation. You can record your own data, and it's a research experience, really. In the slides that are online, you have a lot of resources that we'll try to update. I'm not going to go through all of those, but you're going to get, we're going to talk about data sets, we're going to talk about many data sets apparently, annotation resources, speech recognizers, speech analysis tools. We're going to talk about facial expression analysis, possibilities, machine learning toolboxes, and so we want to give you kind of like a broad spectrum of available resources. And for the course project and for the homeworks, I'm recommending to use scikit-learn or Python. For the homework to do the statistical analysis and the visualization, I'm recommending to use R or MATLAB. There is possibility to do that in Python, but I'm not an expert in this. I think you can do plots in Python, and on the blackboard I put up a link to 3 Linda tutorials, one on Python and data analysis, one on R and data analysis, and one on MATLAB as an introduction. So if you want to do some MATLAB, you're free to do that too. So I would just, I looked at a little bit, like the Python one yesterday night, and I was like, it's kind of neat. So it's not a bad tutorial, so I would recommend to look at it. And the links are also on the blackboard, so you're going to be, it's a playlist that I created. If you find other things that I should put on that playlist, please just send the link or put it on the discussion board, and then I'll be happy to add that. I only did like 5 minutes of search on Linda yesterday. All right, that's it. Are there questions? Oh yeah, one thing. So we are going to have our first discussion on Monday in a week. Mathieu already put up the reading assignments for that week. Reading assignments here. So these are the reading assignments for the human communication, and then for the vocal messages. And so these are two discussion sessions that are going to be happening next week. So we have one on Monday and one on Wednesday. This is because we're having Labor Day coming up, and so we are going to miss one lecture. We need 4 people for each of those to sign up. On Wednesday, this Wednesday, we're going to bring a sign-up sheet, and we need you to fill that in. Like, we need 4 people, otherwise we're not going to be able to run the discussion. And I'm telling you right now, these are easy papers. It's a little bit to read, yes, but these are easy to understand, and there are, like, you can find millions of videos and, like, talking points on these. So I would sign up for these 2 discussions, because it's not going to get easier. Okay? All right. Cool. So we're going to have this on Wednesday. We're going to have 4 people sign up for each of those. So we're going to have the first 8 being covered. And so it's always going to be 2 individuals together present one topic. All right? Cool.